So now that we have our dashed lines showing the amplitude at 7 and 1, and we have the basic graph of 3 sine 2 theta plus 4, now we need to implement the phase shift. So we're going to shift the graph pi over 2 units to the right. So now we have our dotted line is the basic graph of 3 sine 2 theta plus 4, and we're shifting that pi over 2 to the right. So you can see that where the original sine function started here at the origin and went up, shifting pi over 2 to the right starts the function at right here, pi over 2 and 4, and then it moves up. So basically this is a quarter of a full circle that's being shifted by. That's why you can see it. The graph looks very busy and confusing. Hopefully this will make more sense when we do this in class. But the solid line here is the correct answer for 3 sine of 2 times theta minus pi over 2 plus 4. Here's one to check your progress on for example 3. Go ahead and pause the video. Work out the problem. You're looking at 2 cosine of 3 times theta minus pi over 4 minus 2. You need to find the amplitude, the period, the phase shift, and the vertical shift. So go ahead and work that out. Pause the video as long as you need, and then advance to the next slide when you have your answer. Okay, our answer this time is C. The amplitude is 2. You can see that number here. The period is 2 pi over 3. You take 2 pi and divide it by this number. Our phase shift is pi over 4. You can see that here. And the vertical shift is -2. You can see that here. Okay, looking at example 4, we have another real-world problem. This is about a wave pool. So it says the height of water in a wave pool oscillates between a maximum of 10 feet and a minimum of 6 feet. The wave generator pumps 3 waves per minute. Write a sine function that represents the height of the water at time t seconds, and then graph the function. So the first thing we want to think about is finding the midline of this graph. And so we know the graph oscillates between 10 feet and 6 feet. So the way you find the middle is just the average of those two numbers, which is 8. So the midline of our graph is going to be y equals 8, which means that our vertical shift was 8 units up above the theta axis or the x-axis. The next thing that we're going to do is find the amplitude. So if the midline is 8 and the waves go between 10 and 6, that means the amplitude is 2 because it's 2 units up to 10 or 2 units down to 6. Step 3, we're going to find the period. If there's 3 waves per minute, that means that there's 1 wave every 20 seconds, so the period is 20 seconds. The period is equal to 2 pi over b, so you need to solve for b here, and when you cross multiply, you're going to get that b is pi over 10. And then step 4, we need to write our equation. To find h, which would be our shift. Oh no, that's the height, sorry. H is the height of the wave, t is the time. They're just using t and h as our variables here instead of y and theta. Fill in the basic format of an equation, a times sine of b times your variable minus 0. There's no phase shift here, plus 8. We know a is 2, we know b is pi over 10. T minus 0 is just going to simplify to t. And so if we look at our next slide, our function is 2 sine pi over 10 times t plus 8. And if we graph that function, this is what it's going to look like. You can see the midline, if this is 10, 9, 8, 7, 6, 5, 8 right here. This would be the middle point, the midline of the graph. It goes up to 10, it goes down to 6. Every 20 seconds you have a full rotation, so we start at the midline, go up to 10, midline down to 6, back to the midline. We do that one whole rotation in 20 seconds. We have a check your progress problem for example 4. Go ahead and pause the video, read through the problem. It's very similar to the one we just did. Work out your answer. You need to come up with the equation, so you got to find the amplitude, the period, and the vertical shift for this problem. Once you have your answer, go on to the next slide. Okay, our answer this time is choice A. If we go between 8 and 4, the average is 6, so that's our vertical shift right here. 5 waves per minute. You need to figure out one wave in how many seconds. 5 waves per minute means one wave every 12 seconds. Doing 2 pi over 12, you get pi over 6. And our amplitude is 2 because between 6, if 6 is the minimum, it's 2 up to 8, or it's 2 down to 4. Choice A is the answer. And that brings us to the end of Unit 4, Lesson 8 on translations of trigonometric graphs.